Hi students, welcome back. In today's video, we're going to do some questions from assignment 5.4, solving logarithmic equation. This is a very fulfilling assignment, trust me, because basically you just need to apply the laws of the logarithmic functions and you will find a lot of fulfilling moments because the problems are really manageable, really manageable. So if you have not been finding success in doing math recently, right? This is one assignment that you should really try and stick to it to the end. Right, let's start off with some basic questions. Question 1b. If you're given the logarithmic equations, so you ask to find the values of x, and x happen to be the base of the logarithmic equation. Right, so we're going to convert this into index form. Right, so the base is x. So basically, it's just x to the power of 2 equals to 9. So x can take in two values. It can be positive 3 or x equals to negative 3. All right, however, we have to reject this guy. All right, why we need to reject this? Because if you were to recall, okay, if you were to recall for log functions to be defined, right, the base cannot be 1 and the base must be more than 0. Y also must be more than 0. So therefore, okay, therefore, x equals to negative 3 needs to be rejected. Right, hence the only answer you have is x equals to 3. Okay, right. So this is my explanation. So once you have understood why you need to reject x equals to negative 3, so your solutions, your answer can just be this part here, and then with a bracket reject underneath x equals to negative 3. Okay, this is my explanation. Right. So your actual solution can just be this part here. All right. So let's look at part C. Okay, part C. We're going to use the same concept as what we have applied for 1b, that is to change it into index form. So zoom into the base. Here the base is base 4. So 4 to the power of x equals to 8. All right, and what is the connections 4 and 8? Yes, you can actually write both numbers as 2 to the power as a power of base 2. So 4 is 2 to the power of 2. And you can write 8 as 2 to the power of 3. So from here you have 2 to the power of 2x equals to 2 to the power of 3. So 2x equals to 3. So x will be 3 divided by 2 equals to 1.5. Right, let's look at question 3. Okay, question 3 says, ask you to log logarithmics to find the values of x for each of the following equations. Okay, so when they say that take logarithmics, please do not jump into conclusions to straight away bring log to both sides. Okay, I'll explain to you what I mean by saying that. How do you start by doing 3C? Right, you actually should just simplify the x equation first. Right, you need to make 7 to the power of 2x a subject first. Okay, so subtract 4 on both sides. So 1 minus 4 will give you negative 3, and then multiply negative on both sides to get 7 to the power of x equals to 3. Alright, so from here, then you take log. Okay, remember, from here, then you take log. Alright, so you can apply the power law. Bring the 2x down. And you can divide by 2 log 7 on both sides. So x will be equals to log 3 divided by 2 log 7. And use a calculator to evaluate, express the three significant figure, you get 0.282. So for solving logarithmic equations, right, you must remember that you have to apply the laws, the product law, the quotient law, power law, change of base. Okay, you cannot use your own law. You cannot treat logarithmic like, treating it like what do you call that, solving a equation involving algebra. Okay, you must treat logarithmic equations with tender and care. All right, let's look at D. Okay, likewise, I need to make 3 to the power of x plus 1 as a subject. So the common mistake made is, yes, this is what I wanted to caution you, right? Because the question says take logarithmics to both sides, and then you'll be very happily, do what I've just shown here, right? Happily apply, bring log to both sides, and then you apply algebra. Okay, simply, like algebra, like x times a minus b will gives you xa minus xb. Okay, so that is using that is fine if you are using algebra, but we're talking about logarithmic equations, so we need to use the law that is given, and obviously there's no such law. Okay, there's no such a law, right? There is no such a law. As in, what I mean there's no such a law means there is, let me write it out, there's no such a law that log bracket m minus n gives you log m minus log n. Okay, don't have at all. All right, if you cannot remember what are the laws, please go and revisit the 3 laws. Okay, right, so therefore you can't do that, huh? So therefore you can't do that. So basically you just need to add 12 on both sides to make 3 to the power x plus 1 the subject. Then you can bring log to both sides. Okay, having said that, right, there's also another common mistake that some students will make, because when you apply the power law and you happily bring your x plus 1 in front of a log 3, and a lot of you will write it this way. Okay, when you write it this way, you must be careful, because this means x plus log 1 times log 3 is just log 3. So when you write it this way, it means x plus log 3. But I don't think this is what you want, right? That is not your idea. Your idea it's x plus 1, the whole thing multiplied with log 3. So that's why you need a bracket here. Very important. Okay, you need a bracket here. All right. Okay, so when you have a bracket here, you will get, when you expand it, you get x log 3 plus log 3. Okay, so these are some traps here and there. You need to be careful when you're doing this chapter. Okay, so you expand it, you get x log 3 plus log 3 equals to log 2. And then you subtract log 3 on both sides, and then divide by log 3 and use the calculator to evaluate, you get 1.26. Right, that's it. Okay, so question 8 is really, really easy, because basically what you're given, they have already expressed it so nicely for you. You have log something equals to log something. So if you to recall, if you have log m equals to log n, then m is equals to n, right? So all we need to do is, just compare this guy with this guy. Right, and then you can just expand the left hand side. Okay, and then bring everything to the left hand side, so you get a quadratic equations where you just factorize it and find the 2 values of x. Now most of the times you would have to really substitute the values of x into the original equation, because not all the answers are, not all the answers are accepted. Because if you to recall that you have to treat log with tender care. Okay, so for this to be defined, there's certain condition, right? A cannot be 1, a must be more than 0, and y must be more than 0. So therefore, when you substitute x equals to -1 back into the original equation, right? Yes, okay. This guy here, right? When you substitute into this, the right hand side, you will get log -3, which is defined. So therefore, you need to reject x equals to -1, okay, and therefore x equals to 3. But it doesn't mean that x equals to negative answer means all the time rejected, okay? You need to substitute back into the original equation. Originally meaning this one. This is original equation, okay, the one that you have not touched on it yet. Substitute inside there and see if you are able to fulfill the definitions of your log y base a, okay? All right, let's look at the next question. So next questions, again, it's very manageable, seriously very manageable, because the left hand side, you just need to apply the quotient law. Okay, apply the quotient law. Right, so your m actually, it's just this chunk of thing here, and then your n is just this chunk of thing. Okay, and that will give you log base a m over n. Apply the quotient law. Right, then the next step is to convert it to index form. Okay, So converting from log to index, index to log, this is the most basic. So if you have forgotten how to do it, please revise. Right, so to convert it to index form, just zoom in onto the base. The base is base 3, right? Base is base 3, so 3 to the power of 3 gives you whatever whatever that it is. Okay, and then you can multiply both sides by x minus 5. All right, 2 to the power of 3 is 8, so that will gives you 8x minus 4t. And then you can expand this, and then again you will if you bring everything to the left hand side, you get a quadratic equation where you can just factorize it. So can you see the process is really very fulfilling. If you know how to do the first few questions, know the laws well, right, you find that a lot of times you can just get the answer, and it's a very happy moment when you get the answer. Okay, so we just factorize it. Right, so again we need to check whether the answers are valid or not. So when you substitute x equals to -4 into the original equation into this guy here. Okay, I did not finish what I need to say in the previous slide. So we need to substitute the values you get for x in the original equations, and if it does not satisfy the definitions of the log, then you have to reject it. Okay, let's look at question 9. Question 9 is there's some scaffolding here, and the scaffolding is you are supposed to use some kind of substitution. All right, substitute log x base 3 to be u, and then solve the equation. So usually when they ask you, when there's some help given to you, just use it. Okay, don't use otherwise. Just use the help that's given to you. Right, so all we need to do is, yes, we need to change this term here. We need to change it to base 3, so that we can make use of the substitution, right? So you need to revise on the change of base, which is not difficult lah. Not difficult. I've already written it down on the screen for you, right? So in this case here, yes, first of all, understand that yes, 3 log 3 base x can be written as 3 over 1 times log 3 base x. Okay, this is some kind of the algebraic manipulations that you need to know. Then from there we change it to base 3. All right, so I need base 3 here. Okay, and then the original base go to the denominator, and then the 3 go to the numerator. Now log 3 base 3 is a special case. If you remember, log 3 base 3 is a special case that gives you 1. And then you use substitution. All right. Okay, so here comes the algebra part also. To make it a quadratic equations, you just have to multiply u on the left hand side and also u on the left hand side, right hand side and left hand side. All right, and then expand your left hand side, and then bring everything to the left hand side. You get quadratic equations, factorize it. Okay, we are not done yet. Why we are not done yet? Because use is a substituted value. It's not the original value. What we are finding is the value for x. Okay, so when u is equals to -3, that means log x base 3 is equals to -3. Convert to index form. So x is 3 to the power -3, which is 1 over 27. So likewise, when u is equals to 1, log x base 3 is equals to 1. Convert to index form. X is equals to 3 to the power 1 equals to 3. Right, so that's question 9. Right, so basically by now you should know if you are given two unknowns, two variables x and y, and two equations, then we all know that we need to solve them simultaneously, right? So what can we do to log x base y equals to 2? Right, just change it to index form. All right, just change it to index form. So y to the power of 2 equals to x, and then substitute that into your equation 2. Okay, you get y times y squared times y equals to 8. So y cubed is equals to 8. So y is cube root of 8, which is 2. So after finding y equals to 2, just substitute back into your equation xy equals to 8, and then you get x equals to 4. So can you see how fulfilling, how simple this is? Yes, I'm sure you have built up your confidence. Okay, so let's look at question 13. Sometimes the questions can be like, look very difficult, look very complicated. Some problems can, you look at it and it thinks that, wow, so difficult. Like so many, what do you call that, loops here and there, entangles here and there. But actually, if you just decompose it, break it down into simpler terms, you will find that it's easier than what you have earlier thought of. So how do you break it down? Yes, so if that complicates you, you just replace this guy with a, and then let's see what happens. Yes, then you will have log a base 4 equals to log 2 base 4. So since we have both log base 4 on both sides, a is equals to 2. But you must always remember a is a substituted value, so you have to put back into the original value. And that complicates you again. You just replace the guy with a letter y. Okay, and then you will get log y base 3 equals to 2. You convert it into indexed form, 3 to the power of 2 equals to y. And then just put that y because you actually let y to be log x base 2. And again, perform conversions from log to index form. So this question is just converting. You just keep converting from log to index, log to index, log to index. And the answer you get will be 512. Okay, so question 19 is slightly harder. Why slightly harder? Because it involves the rules of the indices, and most of the time you would have already forgotten the rules of the indices. So I've done you a favor by listing it down. Okay, there are more rules than that. There are actually 8 or 9, but most of the time we just need to use this few. All right. So what I've done is that I've actually highlighted for you which rule to use. The one in yellow, you can just use the first one to break it down. So for this question, it's actually quite easy. You just keep breaking it down and then rearranging it. And then, yeah, things like 3 to the power 1 times 2 to the power negative 2, you can just use a calculator to evaluate. And yes, and the one highlighted in green, you can see that I actually use that rule highlighted in green to combine them into 6 to the power x. Right. And of course, you can easily take 21 divided by 3/4. And you have 6 to the power x equals to 28. And that is solving exponential equation already, right? Where, how do we solve it? You just bring log to both sides. Yes, apply power law. So you get log 28 divided by log 6 gives you 1.86. Okay? Okay, so I must admit that 24 is really much harder. 24 is really much harder than the other questions. Why? Because you are given two variables x and y, so you're expected to form two equations, solve them simultaneously. And yeah, so first thing first is that let's list down all the rules of the indices. Okay, and then let's see which one we can use. Yes, the one highlighted in green, you just use the one highlighted in green. The one highlighted in green, use that. Okay, right. So basically, you just apply, just break it down. Okay, break this down into 4 to the power x times 4 to the power 3. Break this down, and then express everything to base 2. Okay, and the one highlighted in yellow, just use the one highlighted in yellow. Sorry, I'm having a very bad cough. And then what's next? Yeah, and then yeah, so now you have all same base 2, right? Same base 2, base 2, base 2, base 2, base 2. So you can just add the power. So that will be 2x plus 6. That will be 5 plus x plus y. Okay, we're going to make y the subject. And then substitute it into your 9 to the power x plus 3 to the power y equals to 10. And we're going to decompose further because 9 can be written as 3 to the power of 2. Okay, so it's a series of keep breaking down, apply the rules of indices and keep breaking down. So it's actually very distressing. Distress, yeah, distress. Yes. It's a process of it's a distress process because you just keep breaking things down, keep breaking it down. See? Right. And then finally, we're going to do some substitution. We're going to substitute 3 to the power x to be a. Okay, and then you can factorize it. Right, so remember a is a substituted value. It's a substituted value for what? 3 to the power x. Right, so we need to reject the first one because 3 to the power x is an exponential function. It's more than 0, and then your right hand side is negative. So you cannot have something positive because the negative. So 3 to the power x equals to negative 5 is rejected. So therefore, we only have 3 to the power x equals to 2, and that is a what? Exponential function. So we bring log to both sides. So can you see the concepts keep repeating? So if you know your concepts well, right, you can just solve all the questions in this exercise. So x will be log 2 divided by log 3, and that gives you 0.6309. Final answer is 0.631. We need 0.6309 to find the values of y. Okay, and that's it. All right. So even though it's highlighted in red, supposed to be like advanced question, but actually it's not really that advanced. It's just that you need more steps. Right. So this question is similar in concepts to the one we have done 24. Really similar. So first thing first, let's list down all the rules of the indices. You see, I keep listing it down so that you can remember it. Okay, so I'm going to highlight to you what I need to use. So can you see that under the rules of indices, usually we just use the few of them only. We don't need to use all the 8 or 9 of them. Just use a few of them only. Okay, the yellow one use the yellow one, the blue one use the blue one. Okay, you have to wait for the green color to come out. Okay, because I'm very tired. I'm really very tired to go and redo it. Okay, so we just keep breaking it down. Okay, the yellow, keep breaking it down. This one. We'll give it 3 to the power of 2x times 3 to the power of 4. And this one will give you 5 to the power of x times 5 to the power of negative 2. And this one use the one highlighted in blue. So it's a series of keep breaking it down. Okay, and then finally, what do I do? Yes, it's similar in concepts to 24. Things like that, you can just use a calculator to evaluate. Okay, right. And then finally, I'm going to divide both sides by, this one will give me 45 to the power x. So divide both sides by 45 to the power x. Yeah, and then this guy here, I can use this, the one highlighted in pink for you, to combine them into 675 over 45 to the power x, which is 15. 675 divided by 45 is 15. So 15 to the power x is equal to 81 over 25. Okay, right. Okay, so from part 1, this is what we have found, right? 15 to power x equals to 81 over 25. Then you just bring log to both sides, and then apply the power law, bring your x to the front. Okay, and then to find x, you just take log 81 over 25 divided by, I think I should bracket it. Yes. Okay, so log bracket 81 over 25, close bracket divided by log 15. Use a calculator to evaluate, you get 0.434. And can you believe it? We have come to the end. Yes, and I think it's really an achievement. Okay, why? Because we have completed it. That's it. So it's an achievement.